Hello students, Ms. Slyman here with your next example. In this example, we're saying that 3x squared minus 5x plus c is divided by x plus k. The quotient is 3x plus 1 and the remainder is 3. Well, let's think about our algorithm that we had before, which said that a function is equal to the divisor times the quotient plus the remainder. So let's work this out. Our function is our 3x squared minus 5x plus c. We're divided by x plus k, that means the divisor. The quotient is 3x plus 1, and the remainder is 3. So if these two things are equal, then that means they're the same. So let's expand them and set them equal to each other. The left side can't be expanded any. The right side is going to be 3x squared. X times 1 is plus x. K times 3x is 3kx. And k times 1 is k. And then I still have this plus 3 on the end. So now, thinking about my like terms, we would have, let's move everything to the same side actually. So I'm going to move all of this over to the right and set it equal to 0. So 3x squared minus 3x squared plus x plus 3kx minus 5x, oh sorry, move it to the other side, plus 5x plus k plus 3 minus c equals 0. Well, 3x squared minus 3x squared, that already equals 0. If I'm going to equal 0, all of these x terms are going to have to cancel out. So let's factor out an x from these. That means I'm going to have 1 plus 3k plus 5 x's. And then I also have k plus 3 minus c. Since this equals 0, I have to have no x terms and no constant terms. So this is going to be 6 plus 3k has to equal 0. Well, looking at that, k has to be negative 2. And now over here, this also has to equal 0 because the only way to end up with 0 is 0x squared, 0 x's, and 0 constants. Negative 2 plus 3 minus c has to equal 0. That's a positive 1 minus c equals 0. That tells me that my c value has to be negative 1. My c value has to be positive 1. Let's go back so 1 minus c equals 0. That means c has to be equal to 1. So again, looking at our coefficients and making them equal to 0, or looking at the coefficients on separate sides, we could have done as well. So 3 has to equal 3. That's true. Negative 5 would have to equal 1 plus 3k. So we end up with the same sort of solution, and c has to equal k plus 3. That's another way I could have set up this system, and I would have gotten the same results. So there's example 7. Of course, I could come back in and plug these in and check my answers. That's always a good thing to do. And I'll see you in class. Come with any questions you have.